Students, welcome to Sunil's tutorial. I'm Sunil Gilwani and today we'll be doing this chapter as electrons and photons. Let's try to understand certain concepts today. This is a metal sheet. Okay. Now let's assume that light energy is incident on it. Let us assume that light energy is incident on it. Right? Light energy is going to supply it with some amount of energy. Let us see how the energy is going to be used up. Now there is going to be some electron that is going to be inside. A part of the energy is going to be used to bring this electron to the surface. A part of the energy is going to be used to bring the electron to the surface, and the remaining part of the energy is going to be used to give kinetic energy to this electron. Once light energy is incident on a photoelectric material, certain part of the energy is used to bring the electron to the surface, and the remaining energy is used to give kinetic energy to the electron, and that's how the electrons then remain in that space between the plate and the cathode. Right? They remain in that space, and once the anode is kept at or the plate is kept at a positive potential, they get attracted and photoelectric current flows through it. So that's the concept. Now this concept was put forward by Einstein in an equation which is called as HV is equal to half mv max the whole square plus W0, right? Where HV stands for the total energy that is incident on the photoelectric material. H stands for Planck's constant. V stands for frequency of the incident light. Right? He said that the total energy supplied is equal to W0. W0 stands for work function. What is work function? Work function is the minimum energy that should be supplied to a photoelectric material so that the electron which is there inside is brought to the surface. What is work function? Work function is the minimum energy that should be supplied to a photoelectric material so that the electron which is inside is brought to the surface, and after that the remaining energy is used to give maximum kinetic energy to the electron. Right? Do we get this thing clear? So thus he said that the energy of incident photon is the sum of maximum kinetic energy ejected by the photoelectron and the energy required to release the photoelectrons from the surface of the material. Fine, do we get this in clear? Can you just write this down, please? State Einstein's equation. State Einstein's equation. State Einstein's equation. Einstein's equation states that Einstein's equation. Einstein's equation states that, write this equation down, HV is equal to half mv max square plus W0. HV is equal to half mv max square plus W0. Right? Where m is the mass of the electron, m is the mass of electron, v is the frequency of incident radiation, small v is the frequency of incident radiation, frequency of incident radiation, h is equal to Planck's constant, and V max is the maximum velocity of the emitted photoelectrons. Is the maximum velocity of the emitted photoelectrons. Is the maximum velocity of the emitted photoelectrons. and W0 and W0 represents the minimum energy required. W0 represents the minimum energy required to release the electron from the emitting surface. To release the electron from the emitting surface. It is also called as the photoelectric work function of the material. It is also called as the photoelectric work function of the material. Thus, the incident photon energy is equal to the incident photon energy is equal to the energy required to release the photoelectrons from the surface. The energy required to release the photoelectrons from the surface and the kinetic energy of the ejected photoelectron the maximum kinetic energy of the emitted photoelectrons. Next, explain the characteristics of photoelectric effect. Explain the characteristics of photoelectric effect using Einstein's equation. Explain the characteristics of photoelectric effect using Einstein's equation. Now guys, if kinetic energy of the emitted photoelectron is 0, then the frequency of the incident light will be equal to the threshold frequency. If the kinetic energy of photoelectrons is 0, then the frequency of the incident light will be equal to threshold frequency. Now by Einstein's equation, HV is equal to half mv max square plus W0. So I can say that HV, V can be written as V0, kinetic energy is 0 plus W0, right? Thus I can say that W0 is equal to HV0. Therefore the work function can be given as defined as Planck's constant into the threshold frequency, right? That's the minimum frequency required. That means if the frequency reduces below the threshold frequency, then the electrons will not be emitted only. Thus, Einstein's equation explains that a minimum frequency is required for emission of electrons. Fine, do we get the same here? The kinetic energy of the photoelectrons emitted will go on decreasing if the incident energy or incident frequency goes on decreasing. The kinetic energy of the emitted electrons will go on decreasing as the incident frequency goes on decreasing. At a particular point of time, at a particular incident frequency, the kinetic energy will become zero. That is the minimum incident frequency that is required for emission of electron. If the frequency falls below that, then electrons will not be emitted only. Fine, do we get this thing clear? Now, if I substitute this value of W0 back in Einstein's equation, substitute, I'll get HV is equal to half mv max square plus HV0. Therefore, I can say that HV is equal to half, yeah, that should be your, or I can say HV minus HV0 is half mv max square. So H common, V minus V0 is equal to half mv max square. That means the maximum kinetic energy that is going to be supplied to the photoelectrons is going to be the difference between the incident frequency and the threshold frequency multiplied by Planck's constant. The maximum kinetic energy with which the electrons are going to be ejected is going to be the difference between the incident frequency and the threshold frequency multiplied by Planck's constant. So here we also come to know what will be the maximum kinetic energy, right? So those are the things that you come to know from Einstein's equation. Can you just write this down, please? First, the kinetic energy of photoelectrons, the kinetic energy of photoelectrons emitted will go on decreasing. The kinetic energy of emitted photoelectrons will go on decreasing if the frequency of the incident radiation is decreased. The kinetic energy of the photoelectrons emitted will go on decreasing if the frequency of the incident radiation is decreased. If the frequency of the incident radiation is decreased. Finally, at a certain frequency, the kinetic energy of the emitted photoelectrons, finally at a certain frequency, the kinetic energy of photoelectrons will become zero. Copy this down, guys. Copy from here to here. Copy this down. Done? Answer same thing. Thus, continue. Thus, if V is greater than V0, then photoelectrons are emitted and if V is less than V0, if V is greater than V0, photoelectrons are emitted. If V is less than V0, then photoelectrons cannot be emitted. Thus, photoelectric emission occurs. Thus, photoelectric emission occurs only when the incident frequency is greater than a certain frequency V0. Only when the incident frequency is greater than a certain frequency V0, called as the threshold frequency. Certain frequency V0 called threshold frequency. And the electrons require energy to liberate from the atom. The electrons require energy to liberate from the atom. This energy is called as binding energy. This energy is called as binding energy. Binding energy is equal to the photoelectric work function. Binding energy is equal to the photoelectric work function. Next, that finishes that. Let's see certain applications. Draw this diagram, guys. How do you use this photoelectric effect? Draw a neat label diagram of photoelectric cell. Draw a neat label diagram of photoelectric cell. everyone finish this, guys? Yeah, take on. A photoelectric cell consists of a highly evacuated photoelectric cell consists of a highly evacuated glass bulb with two electrodes, cathode and anode. Now this is the glass bulb with these two electrodes, cathode and anode, right? Let's continue, please. The cathode is a semi-cylindrical plate. And its convex surface is coated with photosensitive material. Right, this is that convex surface, inner surface, which is coated with photosensitive material. Okay, right. When light entering the tube falls on the photosensitive material, it emits electrons. So light falls on the surface and it emits electrons. Fine. Next, the anode is a rod of platinum. Which is fixed along the axis. Right. So this is your anode, which is fixed along the axis. Right. So you have light falling on the cathode. Cathode will give out electrons, which will remain in the space between the cathode and the anode. And if the anode is connected to a positive potential, these electrons will be attracted by the anode. Fine, do we get this? This is how a photoelectric cell looks like. This is how you represent it symbolically, and this is how you connect it in a circuit. In a circuit, you have to make sure that you connect the cathode to the negative terminal. Fine, do we get this thing here? This finishes the theory of this chapter. Let's start with the numericals of the chapter, guys. An electron beam is passed. Let's start with the numericals, guys. An electron beam is passed through electric field. An electron beam is passed through electric field, of 4,500 volts per meter, and magnetic field of 1.5 into 10 raised to minus 4 Webers per meter square. What is the velocity of electrons? What is the velocity of electrons? Thomson's experiment. Velocity of electron is nothing but the ratio of electric field to magnetic field. So V will be equal to E upon D. You have the value of E, you have the value of E. All you have to do is divide and get the answer. The answer for this should come to 3 into 10 raised to 7 meters per second. Next, take on next one please. Electrons pass undeviated. Electrons pass undeviated through an electric field of 5 into 10 raised to 4 newtons per coulomb and magnetic field of 4 into 10 raised to minus 4 Webers per meter square. Find the velocity of electrons. Replica of the previous sum guys, same formula, V is equal to E upon D. You have both the values, divide and you should get your answer. Right? Take our next sum please. In Thomson's experiment, potential difference of 500 volts is applied and deflection of the spot is obtained. To bring the spot to its original position, a magnetic field of 1 into 10 raised to minus 8 Webers per meter square. A magnetic field of 1 into 10 raised to minus 8 Webers per meter square is applied. Find the velocity of the beam if the distance between the plates is 0.5 centimeters. If the distance between the plates is 0.5 centimeters. Now first of all, let's find out electric field. How much electric field will be generated? The electric field is nothing but V upon D. It is the ratio of potential difference to the distance between the plates. So you will come to know your strength of the electric field here. Once you have this, then you can find out the velocity of electrons, which is nothing but E upon B. First you find out the strength of the electric field and then you can find out the velocity of electrons. The answer for this should be 10 to the power, velocity of electrons is 10 to the power of 7 meters per second. Next, take our next one please. In Thomson's experiment, the velocity of electrons is 10 to the power of 8 meters per second. The velocity of electrons is 10 to the power of 8 meters per second, and the strength of the magnetic field is 3 into 10 raised to minus 3 Webers per meter square. If the distance between the plates is 0.5 centimeters, find the potential difference applied. Find the potential difference applied. Now guys, first of all I can find out velocity of electrons as ratio of electric field to magnetic field. Therefore I'll come to know that strength of electric field is velocity of electrons into magnetic field. But we know that strength of electric field is nothing but potential difference upon the distance between the plates. Therefore I can say that V upon D is equal to VB. Potential difference upon distance between the plates is velocity into magnetic field. Hence I can say velocity of electrons is potential difference is equal to velocity into magnetic field into distance. To cross multiply you will get this answer. The answer for this should be 1500 volts. Next, take on next one please. An electron beam has a velocity of 10.2 into 10 raised to 7 meters per second. And is bent in a circle of 6 into 10 raised to minus 2 meters by a magnetic induction of, and is bent into a circle of radius 6 into 10 raised to minus 2 meters by a magnetic induction of 10 to the power of minus 2 Webers per meter square. Find E upon M. This was your conclusion of Thomson's experiment. E upon M. E upon M is nothing but B upon BR. The ratio of charge on the electron to mass on electron is nothing but velocity divided by magnetic field into the radius of the circle in which it is moving. You have all the values, all you need to do is substitute and get the answer. The answer for this should be 1.7 into 10 raised to 11 coulombs per kg. Next, take on next up please. Electrons have a velocity of 2.652 into 10 raised to 7 meters per second. Electrons have a velocity of 2.652 into 10 raised to 7 meters per second. In a magnetic field of 0.5 Webers per meter square. If E upon M is 1.76 into 10 raised to 11 coulombs per kg, find the radius of the path. Find the radius of the path. Same formula again, guys. E upon m is nothing but V upon VR, right? So you have to find out R. R is nothing but V upon V into E upon m. You already know the value of E upon m. You should be able to get the radius. Simple, straightforward substitution again. The answer for this should be 3.014 into 10 raised to minus 4 meters. Next, take on next one, please. In Thomson's experiment, potential difference of 1380 volts is applied. Electric field of 12.5 into 10 raised to 4 newtons per coulomb. Electric field of 12.5 into 10 raised to 4 newtons per coulomb, and magnetic field of 5.75 into 10 raised to minus 3 Webers per meter square is produced. Find E upon m and the velocity of electrons. Find E upon m and the velocity of electrons. Now guys, we know that velocity of electrons is E upon v, right? So I know the strength of the electric field, I know the strength of the magnetic field, so I can easily find this out. I can also say that E upon, we have magnetic field but we don't have radius. Okay. Now I can say that kinetic energy of the electrons is half mv square. Kinetic energy of the electrons is half mv square, right? I can also say that half mv square is the charge on the electron and the potential difference. Why is it that the electrons are accelerated? They are accelerated. Now how much they are going to be accelerated depends upon the charge on the electron and the potential difference applied. Therefore I could say that half mv square is equal to E upon v. Therefore I can say that if I cross multiply, I will get v square upon v, 2v is E upon m. I took m on the other side and I brought v here. But v is nothing but E upon b. So I can therefore say that E upon m is E upon v the whole square upon 2v. Therefore E upon m will be E square upon 2v v square. Right? I presume you have all the values E, v and d. Magnetic field, electric field and potential difference. You should get the value of E upon m. The answer for this should be E upon m is 1.71 into 10 raised to 11 coulombs per kg, and the speed of the electrons should be 2.714 into 10 raised to 7 meters per second. Fine? Yeah, maybe not. Right? Do we get this? Okay, we'll stop this here for the day. Thank you very much.